Okay guys, we're going to start with number 13 on the second page. A couple classes I got to number 13, but most of them I didn't. So we'll start with 13. It won't hurt you to hear it again anyways. So the first thing you have to do is read the whole problem and figure out that it's asking us to find the surface area of a prism with a length of 10 inches, a width of 7, and a height of 3. So they give you this formula up here. All you have to do is plug in those numbers into where the formula goes. So I wrote down S equals 2, parentheses, LW means length times width. So the length is 10 and the width is 7. So I have 10 times 7. And then we have a plus sign. And then we have to take the width times the height. So the width is 7 and the height is 3. So 7 times 3 plus. And then we have to take the height times the length. So the height is 3 and the length is 10. So we have 3 times 10. Then we just solve the parentheses. So I wrote surface area equals 2 parentheses, 10 times 7 is 70, plus 7 times 3 is 21, plus 3 times 10 is 30, close parentheses. The next line I'm going to add everything in parentheses, 70 plus 21 plus 30 and get 121. And then all we have to do is multiply that by 2 to get the surface area of 242 square inches for number 13. Number 14 is asking us to complete the table. We have a factored form on the left, expanded form on the right. And factored form is just showing you what it looks like in factored form, and then to expand it, we would use the distributive property. So 4 times 6m gives us 24m, plus 4 times 1 gives us 4. Okay. The next one, we have a half times 10. So you can think of it a couple ways. You can take a half times 10 over 1 and get 10 over 2, and 10 over 2 equals 5. Or you also should know that multiplying by a half is the same as dividing by 2. So 10 divided by 2 is 5. Or you can take a half, which is 0.5, times 10 in your calculator, and you will get 5 that way. Minus, and then we have to take a half times 4, and a half times 4 is 2h. Okay, because 4 divided by 2 is 2. On the next one, they're giving you the expanded form, so you have to go back to the factored form. So that means we have to factor out a number. So the greatest common factor of 10 and 45 would be 5. So we factor that out, we pull that out, and we, instead of multiplying to go to a distributive property, we would divide. So 10 divided by 5 is 2y minus 45 divided by 5 is 9. Check it. 5 times 2y is 10y, 5 times 9 is 45. Here, looks like the greatest common factor of 28 and 48 would be 4. So I'm going to factor out a 4 and divide. 28 divided by 4 is 7, minus 48 divided by 4 is 12a. So we have 4 times 7 is 28, 4 times 12a is 48a. Number 15, we're just identifying the different terms. So exponent here is the number in the top right-hand corner, so that would be 2. Our terms, we have 3 of them. We have 5, 8x, and y to the second power. And we know those are our terms because they're separated by addition and subtraction signs. Our constant is 5 because that is the number by itself. It is constantly going to be 5. It's not going to change. Our expression is the whole thing. 5 plus 8x minus y squared, and it's an expression because it does not have an equation, or an equal sign. That would be an equation. Our coefficient is the number that is with the variable, in front of the variable, so that is 8. If you also wrote 1, I would accept it because we know there's an invisible 1 in front of the y. Okay, on to the back. Number 16, you should have already read, but it's asking for the greatest number of baskets that can be made. So that sounds like greatest common factor. Okay, so we've got 14 oranges, 35 apples, and 28 pears. So what we can pull out or factor out of 14, 35, and 28 is 7. You can also use your salmon colored factor sheet and see that it's 7. 14 divided by 7 is 2. 37 divided by 7 is 5. 28 divided by 7 is 4. So that means we're going to be, the greatest number of baskets we could make would be 7 baskets. And each basket would have 2 oranges, 5 apples, and 4 pears in each basket. The next one, if you've already read it, it's basically they're taking tours and they're leaving every 15 minutes from the Capitol and 20 minutes from the White House. How often do they leave at the same time? So you're leaving every 15 minutes. So 15 minutes, another 15 minutes would be 30 minutes, 45, and 60. And I think this should say in an hour because you have to have a stopping point. That's the National Capitol. The White House, they leave every 20 minutes. So 20, 40, 60. So the question that they don't leave until 60 minutes is the first time they leave at the same time. So how often do they leave at the same time? It would just be one time. Now, but I have to make sure I put in an hour because I have to have a stopping point. I know some of you probably did it like this, and you pulled out a 5, and 15 divided by 5 is 3, 20 divided by 5 is 4, and then the least, these are multiples, so you're finding the least common multiple. So to find the least common multiple, we take 5, that makes an L. 5 times 3 is 15, times 4 is 60. 60 is not your answer. That's just telling you that is the one time, because the question was how often do the tours leave at the same time? Well, they leave at 60 minutes, so that is one time. All right, thank you.